Okay, so first talking about the architecture here, I have four hosts. Host 1 and host 3 are on VLAN 10, host 2 is on VLAN 20, host 4 is on VLAN 30, and all H1, H2, H3 are IPv4 and IPv6 addresses, which I'll talk about in a bit, and H4 is a V6 only host. So, talking about how I achieve default gateway redundancy first. Um, I have configured R1 and R2. Okay, actually, before that, S1 and S2 are, and S3 and S4 are all layer 2 switches, and all the routers are layer 3 switches, and all are Arista CEOS. Um, R1 and R2, I've configured VARP, and I chose that over VRRP or HSRP. Well, that's actually Cisco proprietary protocol, but I chose that over VRRP because it achieves active-active situation. So basically, R1 and R2 both forward the packets instead of R1 or R2 becoming active and standby. So I have three SVIs configured on R1 and R2 as well. And I have a virtual IP for each of these SVIs, which become the default gateway for each of the SVIs. That's about how I achieve default gateway redundancy. And R1 and R2 are RIP neighbors. R1, R2, R3, and R4 are OSPF neighbors. R3, R5, and R4 are eBGP neighbors. R3 is on ASN 63,000, R4 is on 64,000, R5 is on 65,000. So all of them talk eBGP, and R5 is connected to the web server with this IP address that's shown on the screen. Uh, how the hosts talk to web server is basically R5 advertises this 110.0.0.2 and 2090::2 routes to R3 and R4 through eBGP. R3 and R4 basically redistribute the eBGP learned routes into OSPF. So R1 and R2 know how to reach that, and that's how all the hosts know how to talk to the web server. Now, talking about the DHCP server, R2 is configured as the DHCP server, DHCP v4 and v6 both. So it leases out IPs to all the end hosts here, H1, H2, H3, and H4. Then talking about the management, I chose to have a different management switch which connects all the devices, all the switches and the routers and NMAS. Um, so that is much more scalable if we want to add more devices. We could just plug into the management switch. Given the IP address scheme, this is how the IP address scheme looks like for management. I basically have three management subnets, and I've divided each of the devices into three parts. Two switches and two routers are in management one with the subnet, and I have two switches, two routers, and an NMAS in management two, and R5 in management three. So that's about the architecture. Oh, and talking about V6, I basically chose to have dual stack. Basically, all of the hosts, switches, routers, and MES web server all have IPv6 connectivity as well, IPv6 addresses configured. So everybody can talk over V4 and V6. So H4 can basically reach any device here. Now let's see how this works. This is a proof of how everything is working. So I'm logged into host one, which is this host. And first, I will show you the ping connectivity to all the other hosts. So the IP address of H2 is 12.0.0.4, H3 is 11.0.0.5. 12.0.0.4. And as you can see, it's pingable. 11.0.0.5. And that's pingable as well. I can ping the H4's IPv6 address, and that is this one. And that's reachable as well. I will also ping the other IPv6 addresses. This is H2's, this is H3's, and that's how I have all the four hosts be able to talk to each other. Now I will show you how host 1 talks to the web server. And first I will show you with IPv4 connectivity. This is the web server's IP address 110.0.0.2, and it's pingable. And if I do a curl on this, I should be able to see the HTML page that I had configured on the web server. Voila. All right. And I will show you that on the other devices as well. This is host 2 with the HTML page. Host 3 with the HTML page. I'm sorry about that. Host 4 only is an IPv6 address, so I will call the IPv6 address. 6. All right. So H4, all the hosts have connectivity to the web server.